Okay, let's look at 9.3, simplifying radical expressions. So to simplify, we're going to use some of the rules we learned about radicals. So if you look at A, we have the ninth root of x cubed. And normally you say you divide the index into the exponent to simplify, or to see how many variables you can take out of the radical sign. Here we can't take any out, because 9 does not divide into 3. But I do notice 9 and 3 are both divisible by 3, so I can reduce this to become the cubed root of x to the first power. And I don't need to write that one. So the cubed root of x is actually much easier to kind of visualize than the ninth root of x cubed. The kind of the longer way you could have done this is rewrite it at first as x to the 3/9. So write it as a rational exponent, and then reduce the 3/9 to 1/3, and then we know 1/3 is the same thing as the cubed root. Okay, so this is kind of the shortcut way of doing all those steps. For B, we have the square root of n times the cubed root of n. I can't multiply inside the radical sign because these are different indexes. One's a square root, one's a cubed root. But I'm going to write these as rational exponents. This would be n to the 1/2 times n to the 1/3. And then these have the same base of n, so the product rule says when you're multiplying, add your exponents. So 1/2 plus 1/3 is 5/6. And I'm fine if you leave it that way, but in my math lab, they might want you to rewrite it as a radical since that's what you started with. So your index is 6 and your exponent is 5. Okay, let's simplify a couple others. C is very similar to the one we just did, except it's division instead of multiplication. So again, I'm going to rewrite this. This is t to the 1/2, and in the denominator we have t to the 1/4. When you're dividing with the same base, you subtract your exponent. So 1/2 minus 1/4 is 1/4. So again, you can leave it as t to the 1/4 or the 4th root of t. Okay, and for D, we have the cubed root of the square root of n, and I'm going to rewrite this, and I'm going to start with the inside, so the square root of n would be n to the 1/2, and then I'm going to deal with the cubed root and raise this to the 1/3 power. And this makes it a little easier to see. You're taking n to the 1/2 and raising it to the 1/3. So this is the power rule. You multiply 1/2 times 1/3, and you get 1/6. And I'll just rewrite this as the 6th root of n. So the product and quotient rules of radicals that kind of help us simplify. The product rule says that if your index is the same, so if I have the nth root of a times the nth root of b, so it doesn't matter what's under the radical sign, but if I have, let's say, a square root and a square root, you can multiply inside the radical sign. So sometimes we simplify by multiplying, and sometimes we actually break up. This can go either direction. So sometimes we have the nth root of a times b, and we break it up into the nth root of a times the nth root of b. So that's the product rule. The quotient rule is the same idea, except instead of multiplying, you're dividing. So if I have the nth root of a divided by the nth root of b, that would be the same thing as the nth root of a divided by b. And again, this can go in either direction. You can either take 2 and combine them, or take 1 and break it up into 2 separate radicals. Okay. So simplifying radicals. How do you simplify radicals? I'm going to show you, write down a few steps before we actually start simplifying. So the first thing that you want to do is find the largest perfect square if you have a square root. If you have a cubed root, you want to find the largest perfect cube. If you have a 4th root, you want to find the largest perfect 4th root. Okay, 4th power, I'm sorry. So that divides into, I'm going to abbreviate here, your radicand. And remember, that means the number under the radical sign. The second thing you want to do is, once you find the two numbers, so like let's say, for example, you have 50, square root of 50, 25 times 2 is 50. You want to separate your radicand into the product of these two numbers that you just found, that multiply to give you that radicand. Once you do that, you can simplify that perfect square or perfect cube that you found. So simplify your perfect square or cube or whatever it was if it was the fourth root. Okay, and when you're doing this, it's helpful a lot of times to have, oops, let me clear this, a list of perfect squares, cubes, fourths, etc. So here's one I just found doing a search on the internet. X squared here gives me all the perfect squares, so 4, 9, 16, 25. The x cubed, I have my list of perfect cubes. I'm perfect fourths and perfect fifths. So we can use this as we work on some of these problems if we need it. Okay, so we're going to start with write in simplified form. This first one, we're actually not using those rules I just wrote. This says the square root of 2 times the square root of 8. I actually am just going to go ahead and multiply. These are both the square roots. I can multiply 2 times 8 and get 16. And now you can see this simplifies really easily. Square root of 16 is just 4. Okay. For the square root of 50, I actually need to use that product rule. And the goal is I'm going to break this up into two radicals where I have two numbers that multiply to be 50, where one of them's a perfect square. So if I go to look at my list here of perfect squares, you would start with the first number, right, that occurs right after 50. So that would be 49. So I would start here at 49, and you go up until you find the first number that divides into 50 evenly. And now 50 is a lot easier, and I did just mention this, but I can see 49 doesn't divide into it, 36 doesn't, but 25 does. This is your first perfect square that divides into 50 evenly. So I'm going to break up 50 into 25 and 2. So square root of 25 times square root of 2. 25 is a perfect square. 25 times 2 is 50. I'm trying to get an exact answer, which means I don't want to put this into my calculator and get a decimal answer. I want the exact answer, so I need a radical sign here. Now I can go ahead and simplify, and this is where you need to be careful. When you take the square root of 25, this is a perfect square, so this is going to come out of the radical sign. A lot of times I see this left inside the radical sign, so remind yourself that's coming out. Square root of 25 is just 5, and then you're left with square root of 2. So the exact answer for square root of 50 is 5 square root of 2. Okay, let's look at two other examples. So C, we have negative 2 times square root of 12, and you can look at your perfect square list, or since 12 is a small number, it's kind of easy to figure out perfect squares under 12 are only 4 and 9, and it happens to be 4. So we would break up 12 into 4 times 3. This negative 2 is multiplied by whatever you get when you simplify this. So you have the negative 2 out in front times square root of 4. Remember, that means it comes out of the radical sign, is just 2 times square root of 3. And then just simplify. Go ahead and multiply and get negative 4 square root of 3. Okay, for the cubed root, we erase that so we can actually see this cubed root of 54. You're actually going to start with the first number after 54, and you only have 27. And not after, I'm sorry, the first number that occurs before 54 on this list of perfect cubes, and that's 27. And so you have to check and see, does 27 divide into 54 evenly? And so you would go ahead and break this up. Now remember, this has an index of 3, so don't forget that index of 3. Don't drop that, because then it's just a square root. So that 3 is really important. So 54, we divide it by 27, and you get 27 times 2 is 54. We can then break this up. So cubed root of 27, this comes out of the radical sign, that's just 3, and then you're left with the cubed root of 2. So cubed root of 54 simplifies to be 3 times the cubed root of 2. Okay, for 9, we actually can just use the quotient rule and break this up if we wanted to. We could also simplify it right away. But if I use the quotient rule, I could break this up to square root of 9 times the square root of 16. Both of these are perfect squares. Square root of 9 is 3, and the square root of 16 is 4. So this simplifies to be 3/4. Now when I come to this example below and break it up using the quotient rule, I get the square root of 3 over the square root of 25. The square root of 3 cannot be simplified, that's a decimal, so I can just simplify the square root of 25 to be 5. Okay, now let's talk about simplifying with exponents when you have a remainder. So before, when we were simplifying, everything divided perfectly, but in this case it's not going to happen. So remember, our index is 2 when it's not written, and I'm going to divide 2 into these exponents, and I can see right away 2 is not going to divide into 3 and 7 evenly. So first of all, I'm going to draw a square root symbol here, or a radical sign, because I know that I'm going to have some leftover, or some remainder. So we're going to do the same thing we did when it divided evenly. We're just going to divide. So 2 goes into 2 one time, so I can take 1x out with no remainder. For the y, 2 goes into 3 one time, so I can take 1 out, and it has a remainder of 1, so I have 1 that has to stay inside the radical sign. And then for z, 2 goes into 7 3 times, and 2 times 3 is 6, so then I have a remainder of 1, so 1 needs to stay inside the radical sign. So that's how that would simplify. Okay, so let's do the same thing with this example below. Now remember, there could be a number in front of here, and then I would just simplify the number and the variable separately. So the number's just like we did before, and the variable's the way I'm showing you now. So this is a cubed root. I can see 3 does not go into 2 and 10. So evenly, so I'm going to have a remainder. So I'm going to write that cubed root here. And let's go ahead and divide. 3 does not go into 2, so all of that a squared has to stay under the radical sign. Then 3 goes into 3 once, so I can take 1b out. And then 3 goes into 10 3 times with a remainder of 1. Okay, we're now going to use the distance formula since it has a radical sign in it. So using the distance formula, I'm going to show you this formula. I'm not going to derive it, I'm just going to tell you what the formula is. If you have point 1, what I'll call x1, y1, and point 2, which we'll call x2, y2, the distance formula says to find the distance between these 2 points, it's the square root, subtract your x values and square it, plus subtract your y values and square those. So that's the distance formula. Okay, so let's use this formula. First, we're just going to set up the problem. It says your friend and you start off on a trip from the same place. You travel west for 30 miles and then north for 70 miles. So this is you. You travel due west for 30, pretend like that's a straight line, and then due north for 70. Your friend travels east for 15 miles and then north for 45 miles. So these are your two positions. Using your starting point as the origin, by the origin means this point right here is the point 0, 0. Find the coordinates of the two destinations. So for you over here, since you went to the left of 0, your x value is negative, so this is negative 30. And then you went up, so your y value is a positive 70. And then over here, your friend went to the right, so it's a positive 15, and then up for a positive 45. So those are your 2 points, negative 30, 70, and 15, 45. So we're going to need those on the next page in a minute. Okay, so it says, how far apart were your friend and you at the end of your drive? So we need to use the distance formula to find that distance that we had. So remember, we had this point, and I want to know that distance between them. So using the distance formula, it says subtract your x values. So our x values were negative 30 and then minus 15 squared, plus subtract your y values, so 70 minus 45 squared. Okay, you could put everything that's under the radical sign in your calculator to make sure you can get the right answer. The one thing I want you to be careful with, and I see this as a lot, is when you are squaring this number and this number, remember any number squared should be positive. So sometimes I'll see negative 20, 25 when this gets squared. And that's not correct. Remember, you should always have a positive number when you're squaring. So be careful with that. So if you put this into your calculator exactly the way it looks, parentheses negative 30, and then a minus sign, 15 squared, etc., you should get 2650. And then I'm going to get an approximate answer here, since I want to have a visual of how many miles this is. You should get 51.5 miles. So I rounded there. Okay, and then the last thing we're going to look at is the Pythagorean theorem. And so the Pythagorean theorem, let's draw this out first, is when you have a right triangle. So let's say I have a right triangle here. Remember, right triangle means I have a 90-degree angle. The two sides on either side of this right angle are A and B, and then the side opposite the right angle is C, and this is really important, that C has to be that longest side opposite the right angle. The Pythagorean theorem says that A squared plus B squared equals C squared. So it doesn't matter which one is A and B, but it does matter which one's C. Okay, so let's use this. It says Julie is painting a mural on commission. She decides upon a 5 by 9 foot rectangle cut into 4 pieces by its 2 diagonals. She will use 24 karat gold leaf tape for the diagonals. This tape is expensive, so she needs to know to the nearest tenth of a foot how much to buy for both diagonals. So when I'm solving a problem like this, I like to draw a little picture, and I'm not going to use the straight edge right now. I'm just going to do a rough estimate. So this is not to scale. Let's say this is 5 by 9. And then what she's doing is she needs gold leaf tape for the diagonals. I'm actually going to draw a line here and a line here. Okay, so I'm just going to worry about one of these diagonals to start, and then I can double whatever answer I get. So I'm going to just worry about this triangle right there. So if I bring this over here and draw it, I'm looking at this right triangle. Okay, here's my right angle. This is A and B, or B and A, doesn't matter, and C is actually what I'm trying to find. Okay, this is supposed to be a 5. Okay, so using the Pythagorean theorem, I just plug in these values, and I get 5 squared plus 9 squared equals c squared. Go ahead and do 5 squared plus 9 squared, 25 plus 81, and you will get 106. And then to get c by itself, you actually take the square root of both sides. The square root and the squared cancel each other out. Just remember the index here is 2. 2 goes into 2 one time. So that's kind of a long way of writing that. And I only want the positive answer here because we're talking about distance, and you get 10.3. Okay, so that's for one of the diagonals, but I have 2, so I need to double that. So 2 times 10.3 gives you 20.6, and I'm rounding to the nearest tenth, so that's 1 decimal place. So 20.6 feet is how much she'll need.